Hello and welcome to the second of 3 video lectures about the human value of science. It is called Climate Change and explores the question, what does science tell us about climate change? The 3 statements that we will discuss here are agreed by virtually all scientists who study the climate, be they skeptic or alarmist. I think it's safe to call them facts. Statement A. Humans burn fossil fuels. That causes emissions of carbon dioxide to the tune of around 40 billion tons per annum worldwide. And carbon dioxide is a greenhouse gas. That carbon dioxide as a greenhouse gas is not disputed. We'll come to the greenhouse effect later on. The second statement, statement B. Carbon dioxide in the atmosphere has risen from around 280 parts per million before industrialization to 415 parts per million today. And that's us. All or nearly all of that increase is the result of our burning fossil fuels. Next to nobody disputes that. Carbon dioxide is a trace gas. There's very little of it in the atmosphere. 280 parts per million means about 0.03%, and that's gone up from 0.03 to 0.04%. So there's a very small amount of carbon dioxide in the atmosphere and a very small amount has been added. But that addition has had a significant impact with global greening of 10%. The NASA article cited bottom left says that the Earth has become greener over the past 30 years or so, and they have a map of the world showing where that greening has occurred. Elsewhere, NASA has been quoted as saying that on average the Earth has become about 14% greener, and in the article cited here they assign over 2/3 of that greening to human emissions of carbon dioxide. So 2/3 of 14% means the Earth is around 10% greener due to the burning of fossil fuels. Quoting from the NASA article, studies have shown that increased concentrations of carbon dioxide increase photosynthesis, spurring plant growth. Rising carbon dioxide concentrations in the air benefits plants and so benefits the organisms that eat them, like us. So although carbon dioxide is only a trace gas, present in very small quantities in the atmosphere, it has been proven with global greening that increasing the amount of carbon dioxide in the atmosphere through human emissions can have a significant impact. Third statement, statement C. Since industrialization began, Earth's global average surface temperature has risen by around 1 degree centigrade. Everybody comes to nearly the same result with a range around 0.8 to 1.2 degrees C, so around 1 degree C. That's a significant change. If you put it into the context, we went from an ice age to around the current temperature. To get from the ice age to around the current temperature took only something like a 5-degree change. So 1 degree centigrade does not sound like much, but it only takes a few degrees, increase or decrease in the global average temperature to cause major changes to the Earth. The last ice age ended about 12,000 years ago when the last of the ice sheets melted away from North America and Europe. From mile-high ice sheets over places like Chicago to today's grass, forests, farms and cities took a change in the Earth's surface temperature of only about 5 degrees C. And human civilization, we've only existed within a small temperature range, so we don't want to change that much. We know how to live well with temperatures as they have been over the past 10,000 years. So it's best to keep them there if we can. In the previous video lecture on the human value of science called Problems, we looked at the problems facing science today. Here's a refresher. Worrying problems. Worrying problems mean a forecasted effect in the future. Irreversible means if necessary, if not something needs to be done, it needs to be done now. And pervasive, meaning all of us are affected. Climate change is a worrying problem, as we can see from the definition: forecasted, irreversible, pervasive. Forecasted means that not much is happening today. For the vast majority of people, their lives have not been affected. Forecasted means that the main effects will be felt in the future. But any effects would be irreversible. So if, let's underline the word if we want to change things, we have to identify the causes and fix them now. Irreversible means we won't have a second chance. And those forecasted irreversible effects would be pervasive, meaning widespread across humanity. No place to hide. If catastrophe is coming, it's coming for us all. And, as said in the previous lecture, irreversible plus pervasive means theoretically existential. That's in the case of worst case alarmist climate change. And climate change is a wicked problem. Wicked meaning that it is hideously complex. Earth's climate is highly complex. There are a few widely accepted facts, those three above, A, B and C. That's about it on climate change if you want widely accepted facts. And sadly, there are no universally trusted experts. Those three facts, A, B and C, are all we've got when it comes to widely accepted facts about climate change. And contrary to what you might have heard, the science is far from settled. As we'll see, it's a science-led disagreement. Scientists lead the two different sides of the arguments. Scientists who are skeptics and scientists who are alarmists. But before we get into the scientific disagreement, as we must, because it's very important, I wonder if you'd be interested in trying an experiment on yourself to see if you can do empathy. Empathy, the human values approach to worrying, wicked, science-led disagreements. How about that for a title? Don't be scared. You don't have to actually change your mind. You don't have to agree with the other point of view. You just have to try and understand where they are coming from. So as we get into the case for alarmism and the case for skepticism, you probably start with a view of your own. That's normal. That's how we usually approach these kinds of problems. And then we are motivated to look at the strengths of the case that supports our preconceived ideas and the weaknesses in the case that disputes our preconceived ideas. It's called motivated reasoning, and it's a bias we all have, part of being human. So the experiment requires you to try to suspend judgment just long enough to see things from the other point of view. Give it a try. Let's see if you can do it. The two tribes at war over climate change are the alarmists and the skeptics. These are the polite names. There are other less kind names, like hoaxers and deniers. Climate alarmists are intent on sounding the alarm about what they see as alarming climate trends caused by we humans. Climate skeptics see Mother Nature's hand in the rise in the global average surface temperature that we've seen. Climate skeptics don't mind being called skeptical because they believe scientists should be skeptical about some of the claims being made about climate change. Climate alarmists, putting the blame for rising temperatures squarely on the human burning of fossil fuels, want to warn the sinners in time for them to change their ways. The two sides come at climate change from different scientific disciplines. Alarmists start from the physics of the carbon dioxide molecule and the physics of the atmosphere. They develop computer programs that model the inner workings of the climate using standard, long proven equations from fluid mechanics and elsewhere, so to determine different climate states given different levels of carbon dioxide concentrations. Alarmists are laser focused on the carbon dioxide molecule, which they view as a dangerous pollutant. Their job, as they see it, is to use their understanding of the physical universe and estimates of future carbon dioxide emissions, called representative concentration pathways, to make predictions about future climate, including average global surface temperature. Then they can sound the alarm as to how high temperatures are predicted to rise and persuade the rest of us to reduce or eliminate our emissions of carbon dioxide. So climate alarmism is based on the scientific idea that if you understand how a system works, you can model it and you can make predictions and take actions on the basis of those predictions. So their start point is, how does the system work? And then we want to model it, and then you can make predictions, and then you take action on the basis of those predictions. Skeptics, on the other hand, lean heavily on paleoclimate data and temperature measurement, using proxies for the time before thermometers and satellite temperature sensing was developed. Proxies are measurements that can be inferred from the analysis of ice cores, tree rings, lake and ocean sediments, etc. Climate skeptics study how the climate changed in the past, using their observations to gain knowledge about the climate. They point to natural processes like the orientation and distance of the Earth relative to the Sun, which changes from time to time, and changes in the intensity of the Sun's radiation, and the highly complex relationship between the climate and oceans. They don't view more carbon dioxide as necessarily a bad thing, noting that it is the food for plants. It is from carbon dioxide that plants get the oxygen that plants are made of. Plants take in carbon dioxide, keep the carbon for their leaves, stems, etc., and breathe out the oxygen. Climate skepticism is based on the scientific idea that if you have a highly complex system that you don't understand, you should rely on measurements to deduce how the climate might be changing. We can draw an imaginary scale of climate change science and imagine where individual scientists might fit on that scale. And here are 5 people whose work is particularly helpful in understanding both climate science and the climate change issues that face us. Judith Kerry sits somewhere in the middle of this spectrum. As a climate scientist who has written close to 200 climate science papers, she was heavily involved with the International Panel on Climate Change, the IPCC, until breaking with the consensus a few years ago because she felt that the uncertainty of predictions was not being stressed hard enough. She herself stresses the uncertainty inherent to climate science, and her website is a great resource for papers, reports, and articles from across the spectrum. She has been invited to congressional hearings on climate change. Her paper, Climate Change, What's the Worst Case?, uses a possibilistic framework to assess the IPCC computer model predictions. That paper was published in 2019, quarter 3, 2019. In doing so, she provides some healthy, uncertainty-driven skepticism about the more alarmist scenario in this paper I'm talking about, and produces in this paper a plausible worst-case scenario. The paper itself would be hard going for anyone without some ability in statistics, but the introduction and conclusions will inform any open-minded person interested in climate change. Gregory Wright is a retired geologist who has published a handy little app. You can download it onto your phone. It has 60 tables and graphs that support the skeptic's case. He regularly appears on Fox News and other conservative media, making the case that more carbon dioxide is, on balance, a good thing. That's because, he argues, at the start of the Industrial Revolution, the Earth's atmosphere was dangerously low on carbon dioxide. As a bonus, he convincingly cites facts from NASA, NOAA, etc. to debunk alarmist claims of increased extreme weather events today. But not tomorrow, though. David Wallace Wells is a journalist author who has interviewed Earth scientists to help him describe how bad it could get. The result is a best-selling piece of what they call in the trade climate porn. It is very well written and very convincing, with enough material for the scripts of multiple climate apocalypse movies. It meets its design purpose to show just how alarmed we should be at any risk of runaway global warming. The quote his publishers use, "It is worse, much worse than you think," is not just advertising blurb. It's the anti-skeptical conclusion he comes to. Roy Spencer is a meteorologist from the University of Alabama and the US team leader on a NASA program involved in measuring the Earth's temperature. His ebook, Global Warming Skepticism for Busy People, is a well-argued case for skepticism, interspersed with some good, neutral explanations of climate change basics. Plus, at location 1210, a description of the skeptical climate scientists' alternative to climate models, that is, energy budgets. And there is a useful comparison of skeptic and alarmist views at location 415. Cambridge.org is a website with articles where mainstream climate and earth scientists explain what they are doing. Their stated goal is to be clear on climate. And there are many useful articles which explain climate science from the point of view of alarm. The article called How Scientists Estimate Climate Sensitivity is particularly useful as an explainer of some of the key scientific terms, such as climate sensitivity, and summarizes some of the work being done with computer models and their predictions. The next two slides are informed mainly by Roy Spencer's ebook and articles on carbonbrief.org. Okay, so let's take things from the alarmist climate science viewpoint. The carbon dioxide molecule is transparent to incoming visible light, but opaque to outgoing infrared radiation. What that means is that incoming sunlight goes straight through the carbon dioxide molecule, but heat from the surface of the Earth, in the form of infrared energy heading back into space, can be trapped. Therefore, the carbon dioxide molecule traps infrared energy, which warms the atmosphere. That's where the phrase greenhouse effect of carbon dioxide, or carbon dioxide as a greenhouse gas, comes from. Roy Spencer, the renowned climate skeptic, explains at location 816 of his ebook like this. Each carbon dioxide molecule undergoes billions of collisions with other atmospheric molecules every second, which allows carbon dioxide to warm all of the other molecules. So if a carbon dioxide molecule temporarily warms from the gain of infrared energy, it communicates this change with the surrounding air molecules, mostly nitrogen and oxygen, that it collides with. This happens very rapidly, with the collisions happening at least 10,000 times faster than the time it takes for a temporarily warmed carbon dioxide molecule to lose its extra energy by radiating it away. It transfers that energy in the form of heat to the molecules around it and thus warms the atmosphere. And most agree. That's why I'm using the words of a renowned climate skeptic here, because most alarmists and skeptics agree on this point. If you double the carbon dioxide, taking it up from 280 parts per million where it was before the Industrial Revolution, to 560 parts per million, where it's forecasted to be around 2060, then the global average surface temperature rises about 1 degree C. That's called the direct warming. It's all about the physics of the carbon dioxide molecule. As Roy Spencer puts it, the direct warming effect of doubling atmospheric carbon dioxide, which can only be calculated from theory, is agreed by nearly everyone to be about 1 degree C, maybe slightly more. But there are potential amplifiers to this initial forcing: water vapor, ice albedo, methane, carbon cycle. And what comes next comes from Tim Palmer, Dr. Tim Palmer, who's a mathematical physicist at Oxford, who works on climate models with the IPCC and made a video, which I found very useful, called Climate Change, Catastrophe, Hoax, or Just Lukewarm. This explanation is based on his description of these amplifiers. Water vapor. First, water vapor. It's the dominant greenhouse gas in the atmosphere. It has the same properties as carbon dioxide. That is, water vapor molecules are transparent to incoming sunlight but opaque to outgoing infrared radiation, only with a stronger heat-trapping effect. If a warmer atmosphere means more water vapor, which physics says it does, then the initial carbon dioxide forcing will be amplified. In other words, that direct warming of 1 degree will generate more water vapor, which will amplify that initial forcing, that initial direct warming. The second one he describes, ice albedo. This is the effect that ice reflects some sunlight back into space. If a warmer atmosphere melts ice, which it surely will, less sunlight is reflected and the Earth heats up a bit more. That's more amplification of the initial carbon dioxide forcing. The initial direct warming. Third amplifier, methane, which is a stronger greenhouse gas than carbon dioxide, but stays in the atmosphere for less time. But if the atmosphere warms, the fear is that methane trapped in the permafrost of northern Russia, Siberia, and northern Canada will be released, thus trapping more heat and heating the atmosphere up even more, thus amplifying that initial 1 degree of direct warming. The fourth of the amplifiers, the carbon cycle, refers to the fact that carbon is absorbed by plants and the oceans, and if the atmosphere is warmed, this cycle will be changed in some way, again perhaps amplifying the initial warming. Which brings us to the fifth potential amplifier, clouds. Clouds, at higher level they trap heat, at lower levels they reflect sunlight. It's the most uncertain, most important amplifier in climate science. According to Tim Palmer, clouds are the most uncertain and possibly single most important amplifier. If a warmer atmosphere changes the overall patterns of cloud cover, then they could amplify the initial forcing if it means more high-level cloud, or reduce the effect of the initial carbon dioxide forcing if it means more low-level cloud, and vice versa, cooling with the less high-level cloud, and warming with less low-level cloud. As carbonbrief.org put it, clouds are a constant thorn in the side of climate scientists. They cover around 2/3 of the Earth at any one time, yet individual clouds can form and disappear within minutes. They can both warm and cool the planet, depending on the type of cloud and the time of day. And scientists have no records of what clouds were like in the distant past, making it harder to ascertain if and how they have changed. As they, continuing with carbonbrief.org, all this means the global net effect of cloud feedbacks is complex and hard for scientists to model precisely. So the climate is complex, and there are a number of potential amplifiers of the initial carbon dioxide forcing. Particularly uncertain but important is the effect on clouds. The way we try to understand this complexity and uncertainty is through physics. Carbonbrief.org again. At their most basic level, climate models use equations to represent the processes and interactions that drive the Earth's climate. The most important of these are the Navier-Stokes equations of fluid motion, which capture the speed, pressure, temperature, and density of the gases in the atmosphere and the water in the ocean. But these equations are too complicated to solve. They have to be approximated. As carbonbrief.org puts it, climate models are not a perfect representation of the Earth's climate, and nor can they be, as the climate is inherently chaotic. It is impossible to simulate with 100% accuracy. But the climate models are all we have. Physics-based climate models of the Earth can be used to run simulations of how much warming will occur once carbon dioxide concentrations have doubled. This is an explainer from carbonbrief.org written by Zeke Housefather, how scientists estimate climate sensitivity. In other words, the results from climate models have been consistent in predicting that a doubling of carbon dioxide in the atmosphere, which nearly everyone agrees would be the result of human emissions from the burning of fossil fuels, will warm the Earth by between 1.5 and 4.5 degrees C. So a doubling of carbon dioxide in the atmosphere, which is down to us, could result, according to the climate models, in anything between a rise in global surface temperature of anything between 1.5 and 4.5 degrees C. This wide range is due to the inherent complexity of the climate system, which means uncertainty. For many years, estimates have put climate sensitivity somewhere between 1.5 and 4.5 degrees C of warming for a double of pre-industrial level CO2. The middle of that range is 3 degrees C, 3 degrees centigrade. So the models are telling us that humans will be responsible for warming the Earth by around 3 degrees centigrade if we double the amount of carbon dioxide in the atmosphere. That's us. At current emission rates, that doubling of carbon dioxide will occur around 2060, but because of something called the transient climate response, that predicted 3 degrees C of warming won't be reached until nearer the end of the century. But climate alarmists point out that the warming won't stop there if emissions continue. So there will be lags, so the temperature won't. That 3 degrees, if that's correct, that's the middle of that range, 1.5 to 1.4, won't be, because of lags, won't be reached until something around 2100, but it won't stop there. So what alarmists say is that that is alarming. So alarmists, while recognizing the complexity of Earth's climate, the uncertainty inherent in any climate modeling, and the subsequent wide range of any temperature predictions, see in their models that emissions could lead to runaway global warming. Okay, on to the skeptical climate science viewpoint. Climate skeptics have many critiques of climate alarmism. One of them is that alarmists have been wrong before. In 1798, Thomas Malthus is quoted in Wikipedia as saying, the power of population is indefinitely greater than the power in the earth to produce subsistence. An alarming prophecy of doom that has not come to pass, since the population of the earth is now 7 times what Malthus was concerned about more than 200 years ago. In the 1970s, there were alarming newspaper headlines reporting on the extrapolation of climate and temperature trends to make temperature predictions of cooling. These changed rapidly in the 1980s the other way, but the alarmist tone was maintained. 2009, Al Gore said, "There's a 75% chance that the entire North Pole ice cap during some of the summer months could be completely ice-free within the next 5 to 7 years." Al Gore made this claim in Copenhagen on December 14, 2009. Arctic sea ice in summer months has reduced in the last 10 years, but is nowhere near the point of disappearance in summer. In noting these claims, skeptics make a more general point that science doesn't have a great track record when it comes to making predictions of imminent danger. Many skeptics, notably Matt Ridley, produced lists of scientific predictions that turned out to be false. Their point: we should be skeptical when we hear prophecies of doom. Climate skeptics are also point out some dubious behavior by alarmists. It seems that climate science is not always about science. There has been some very dubious behavior, of which here are 4 instances. The manipulation of data. Hacked emails from the University of East Anglia were published in 2009 in a scandal called Climategate. Many of these were easily read as showing climate scientists conspiring to manipulate reports. And there is a constant stream of complaints about alarmist climate scientists manipulating data sets and data records. For more on that, if you're interested in that, try Real Climate Science, one word, realclimatescience.com. The hockey stick graph. A climate scientist, an alarmist called Michael Mann, produced a graph which featured in the IPCC 2001 report, purporting to show that the rise in Earth's temperatures since the Industrial Revolution was something new and unprecedented in the last 1,000 years. There has been much criticism of the methods used to produce the hockey stick graph, which is what it's called, including a congressional investigation by statisticians, the Wegman report, which is worth Googling. Climate 101 video. Al Gore's Climate 101 video purported to show climate dioxide's greenhouse gas effect, but the experiment looks fabricated. You can judge for yourself. Go to whatsupwiththat.com to see an analysis by Anthony Watts. Then there's the consensus. There is a constant repetition of a climate science consensus, meaning nearly all climate scientists agree with the alarmist case. This is rebutted by skeptics in at least 3 ways. Firstly, that it is meaningless because the consensus is only about the fact that the climate is changing and that human emissions are playing a role. Nearly all skeptics agree with the alarmists that human emissions have played some role in the observed temperature rise. The consensus breaks down over just how much of the observed warming is attributable to human activity. Secondly, telling everyone that the science is settled, which, when it clearly isn't, must be just a ruse to avoid debating the science, say the skeptics. And thirdly, in response to a book titled 100 Authors Against Einstein, Albert Einstein said, "If I were wrong, then one would have been enough." Consensus is not a scientific term. It is a political term, say the skeptics. But the main point that climate skeptics make is a scientific one, that the Earth's temperature changes naturally without any human intervention or emissions. This is a graph, comes from www.lwancock.com blog. It's a graph showing temperature in the northern hemisphere over the last 2,000 years. Skeptics would point out that there has been a slight trend downwards in temperature, shown by the solid blue line, over these 2,000 years. Further, there are 5 distinct historical periods, which are the Roman warm period, just short of 2,000 years ago. The Dark Ages cool period, which followed the Roman warm period, which was followed in turn by the medieval warm period, 1,000 years ago. And then temperatures fell into the Little Ice Age, and then we're coming back out again with the modern warm period. These 5 periods are borne out by the writings of people at the time about their local climate. And there is supporting physical evidence. The Mendenhall Glacier in Alaska is melting, that means retreating, and revealing 1,000 to 2,000 year old tree stumps. These preserved tree stumps coincide with the Roman and medieval warm periods. What this shows is that where the Mendenhall Glacier is today stood forests during the Roman warm period. Then the glacier advanced. As it got colder in the Dark Ages cool period, and as the glacier advanced during that period, it smothered the forest. Then the glacier retreated again until forest was re-established during the medieval warm period. Along comes the Little Ice Age and the forest is smothered again by the advancing glacier, only to be revealed recently as the glacier retreats during the modern warm period. What the skeptics point out is that this natural temperature variation was not driven by any changes in carbon dioxide levels. They stayed more or less the same until relatively recently, when human emissions started. CO2 was steady since something between 260 and 280 parts per million. It's been steady over the last 2,000 years. It's only recently, with human emissions, that CO2 has risen. But during those 2,000 years of those warm periods and cool periods, carbon dioxide, let alone human emitted carbon dioxide, played no role in those natural temperature variations. So we've got the temperature record plus those glacier photos giving evidence of natural climate change and temperature variation unconnected to carbon dioxide. There is no accepted theory to explain this temperature variation over the past 2,000 years. That's why it's called natural, because the climate system is not understood well enough to show cause and effect. Skeptics argue that the only thing climate science can conclude from the past 2,000 years of climate history is carbon dioxide is not the climate's temperature control knob. It's been heavy going, I know, but here's the last slide. Before we get into it, do you recall my suggestion that you try and look at this with empathy? That is, suspending judgment just long enough to see things from the other point of view. How did you get on? Were you able to see both sides? No, not easy, is it? And I'm not sure if this slide is going to help either, but here goes. Climate models using ever more powerful computers have been churning out predictions since the 1970s, and Earth temperature measurement has been getting more sophisticated with satellites. So, can't we just compare observations to model predictions and see who's right? Let's try. Roy Spencer, who's our featured climate skeptic, he uses NASA satellites in his day job to make deep layer temperature measurements of the atmosphere. So he should know what he's talking about when it comes to observations of atmospheric temperature. In his book, Global Warming Skepticism for Busy People, at location 1142, there is a graph showing the average of 102 climate models against 3 balloon datasets, 3 satellite datasets, and 3 reanalysis datasets. The caption reads, "Climate models show warming of the global lower atmosphere 67% faster than the average of these nine observational data sets." In other words, observed, that means measured, temperature is significantly lower than what the models are predicting. So the models are wrong by a long way. A climate scientist with data to show that climate models are wrong about global warming. What about the other side? In this article, how well have climate models projected global warming? Zeki Housefather article on carbonbrief.com came to a conclusion as to how well climate model predictions compared to observations. Climate models published since 1973 have generally been quite skillful in projecting future warming. In other words, model predictions match actual observations, actual measurements. A climate scientist with data to show that climate models are right about global warming. Climate change is a wicked problem, highly complex, few widely accepted facts, those 3 on that first slide for the case of climate change, the rest is in dispute, no universally trusted experts, and there is evidence recent warming is part of nature's cycle, but physics tells us to beware the carbon dioxide molecule. Who will resolve this for us? At the moment, not science. Thank you for watching. The next in the series, Understanding Ourselves Through Our Human Values, is the 3rd of 3 video lectures about the human value of science. It is called Human Values Thinking and explores the question, do human values help explain the human condition? It can be found at www.conservatus.com, where there's reasoning that resonates. Conservatus, keep safe, intact, safe from danger, our human values.